Hi, in this video, we will deliver about the discussion and the result of lab session for FPGA design subject, which is prepared by Nuri Izzaz binti Muhammad Zulkifli and Shukia Nur Umama binti Bahazan. The content of the video is from the lab session, which is lab 1, 7-segment counter, and the lab 2, LCD display. For the lab 1, on the 7-segment counter, the purpose of this lab is to design a counter with frequency divider by using the 7 segment on DE2115 board. So first of all, this show the pin-out software to implement into Cycloid 4 layout. And then this is the node assignment for 7 segments counter that we need to assign for each pin by referring to the provided manual. The output for 0099 counter is shown on the DE2115 board after implementing code from divide 10, divide 50, clock gen, clock counter, segdat, and become count 0099 system. The next part on the effect on the counter speed after implementation of the counter at high frequency and low frequency clock. At the high frequency clock, which is when frequency is equal to 100 Hz, is implemented at the clock input, it results in the faster clock counter, and then the counting process becomes faster. When low frequency, which is equal to 10 Hz, is implemented at the clock input, it will result in the slower clock counter, and then the counting process becomes slower. Next, why the component installation and process statement is being used in the count 0099. First, component installation means to use the component in the circuit. It declares the components such as input and output, and then the installation is its interconnection, where the static components may be linked to each other and to form a circuit. The component in this lab is clock gen, segdat, and clock counter. While the process statement is the set of sequential statements that assign values to signals and ensure the count 0099 can be executed at different processes concurrently. The process statement in segdat and clock counter. Both of the coding is performing the behavioral style combination design. For the segdat, it is used the case statement where the selection is made only on a single expression for the execution, while on the clock counter, it is used an if statement where the selection is made for one or no alternative sequence for the execution.
So now I am going to explain about Lab 2 regarding LCD display. The main objective of this lab is to prove that the coding given in the lab manual will produce an output of the Monday to Sunday on the LCD display of DE2115. Next, we need to edit the coding provided to produce an output of January to December on the LCD display of DE2115. After we have pasted all the coding in the coding panel, we need to assign the location of the pins by referring to the manual. After all the compilation are considered a success, the compilation status and hardware setup windows will pop up and the output will be shown on the LCD. Firstly, this is the output for Monday and the coding of it. Then, the output of Tuesday, followed by Wednesday, Thursday, Friday, Saturday, Sunday, and lastly, the VTT controller. A series of binary numbers need to be applied on the board in order to display output on the LCD display. Then, we need to modify the design that shows January to December when switches are toggled. To edit the output of the display, we need to change to the characters. Firstly, there will be output for January, followed by February, March, April, May, June, July, August, September, October, November, and lastly, December. Just like the first task that asks us to display the day, We'll also need to apply a series of binary numbers and manually toggle them on the board in order to display output on the LCD display. That's all we can conclude from both lab of FPGA design. Thank you.